4 to the power of a half times 4 to the power of 2 times 4 to the power of negative 6. Now, it's not really awkward to sort of be able to add the powers, because that's all we have to do. We simply go and add the powers because we're multiplying the indices. Be careful with the negative sign in this case. So a half plus 2 is 2.5, and then you take 6 off that. So if you're looking at that as your final answer, then you've got 4, and then you've got 6 minus 2, which is 4, and then take another half off that, which gives me 3.5. So my final answer will be 3.5. I could leave this as a fraction, so it could be 7 over 2 as my final answer. And that is another example of combinational sort of dealing with indices, which is 4. Maybe a more complex one with division will show you what I mean by this. So let's say we had 8 to the power of 4, and I'm now dividing by 8 to the power of 6. Well, again, this is now subtraction, so it's going to be 8, 4 minus 6, which is 8 minus 2. I could write this in another way because of my rules of indices as 1 over 8 squared. And again, finish that off by writing 1 over 64 as my final answer. So this is the way forward with these indices problems, and it's worth certainly developing and looking at them as test questions for yourself from exam papers. There are many, many examples and illustrations that we can actually go forward with. Sometimes it might be written in a slightly different format that you're not used to. So, for example, 9 2.5, and you might be looking at that and thinking, what do I do now? Because this is a decimal instead of a fraction, and it's still a power number, it's still called an index number. Well, the way to sort of move forward with